Day 22, reactor reboot. Operating at these extreme ocean depths has overloaded the submarine's reactor. It needs to be rebooted. The reactor core is made up of a large three-dimensional grid made up entirely of cubes, one cube per integer three-dimensional coordinate x, y, z. Each cube can be either on or off. At the start of the reboot process, they are all off. Could it be an old model of a reactor you've seen before? Can't remember. To reboot the reactor, you just need to set all of the cubes to either on or off by following a list of reboot steps, your puzzle input. Each step specifies a cuboid, the set of all cubes that have coordinates which fall within ranges for x, y, and z, and whether to turn all of the cubes in that cuboid on or off. For example, given these reboot steps, the first step turns on a 3x3x3 cuboid consisting of 27 cubes. Yep, that all makes sense. The second step turns on a 3x3x3 cuboid that overlaps with the first. As a result, only 19 additional cubes turn on, the rest are already on. The third step turns off a 3x3x3 cuboid that overlaps partially with some cubes that are on, ultimately turning off 8 cubes. The final step turns on a single cube. After this last step, 39 cubes are on. The initialization procedure only uses cubes that have x, y, and z positions of at least minus 50 and at most 50. For now, ignore cubes outside this region. Okay, fine. How many cubes are on? What is 50? Oh, it's 100 by 100 by 100. Great, that's a million. That's bigger than memory. We only need a million bits though. 62,500. That's still too big. What we could do then is look at smaller regions and go over the input several times. So how big a region could we do easily? I wonder how many lines are in the input. We've got 6 numbers per line, although some of them are actually larger than 16 bits. But for now we don't care. If they're larger than 16 bits, we just we only care about minus 50 to 50 for the time being. I don't actually have a way to read in a bigint. Oh, I do. I can read in. Given a string, I can turn it into a bigint. But grabbing out a string, I can't do with scanf. So I would have to do manually. But okay, that's not necessarily a problem. And then, although, if I'm going to do that, would I just look at the length of number I'm converting? And if it's too long, then I just set it to either 50 or minus 50, based on whether it begins with a minus. Otherwise, I pass the number. Anyway, my plan is, we'll read the, assuming it's short, we'll read the list of coordinates into memory, and then we'll go over it several times. So, well, how big a cube can we fit in memory? Can we do 50 by 50 by 50? No. But 25 cubed isn't a problem. So we've got 4 by 4 by 4. We're going to have to do 64 passes of 25 by 25. Well, actually, we can do 50 by 50 if we make it a bit set. 420 lines. So yeah, the plan is we'll do 50 by 50 by 50 subcubes, of which there are 4, and for each one we'll go over the entire input again. So the first plan is to read in the coordinates. So we want to it's going to look like on or off x equals a to b. What does it actually look like? Okay, fine. I think that's a bogey head. Yeah. F puts 2. Oh no, that's not a bogey head. Not obviously, anyway. Okay, never mind. So it's just a comma, no space in between. Oh, so we actually need 7 here. Because we want the first one to tell us whether it's on or off. So to get to the first number, this is 0, 1, 2, 3, 4, 5. Plus 1 more if it's not on. Plus 1 more if it's an F. So we'll have a special are we going to use the bigint thing? We're going to need bigints anyway, I suppose. So hopefully that'll do it. So then we want we'll do this slightly differently. Go past, we'll take a pointer to a string and a character we want to go past, and it will return a pointer to 1 past that character. Well, that'll be fine. We could have done it with structure, probably. So this feels really ridiculous. Now we'll have a list of the instructions. Good, that gets us the instructions in memory, and now I think we'll print them out. Ugh. What's going on? It's happened twice already, we're only 20 minutes in. The sample has 39 cubes on. Is go past not going past? Ugh. That looks right, doesn't it? Okay, well, let's see if it's correctly bounding it at -50 to 50 on the real input. This is incredibly slow. So what I'm going to do is make it output the bounded input in a way that's easiest to pass. So actually we can simply maybe we should have just looked at the length of the number of digits rather than passing it with the bigint thing. I think it didn't give any output because I forgot to call bclose. Bclose will flush the buffer if it isn't already done. I want to make it automatically flush the buffer when the program exits, but I don't have a mechanism for doing that yet. And how long is this going to take? Oh, it's block buffered, isn't it? So we won't find out until it's done one block. So that was at 36 seconds past. And the next block was at 51 seconds past. And there's about 22 lines per block, based on the size of the screen. "15 seconds per 22 lines is 0.7 seconds per line, and actually I recall it was 420 lines. So about 5 minutes to run. Meanwhile, probably some silent contemplation. First thing I realised is I didn't actually check. I can see it on the screen. I didn't check previously that it actually bounded values in the range -50 to 50, but I can see that it does. So that looks good. Darn, this isn't going to be any good because we actually do want to plot points that are at -50, but some of the inputs were further out of range than that. So we'll just put 51 if they're out of range, and then we can distinguish them. The reason we need to be able to distinguish them is that if it goes from -1000 to -500, then we don't want to plot any points. So we don't want to say it goes from -50 to -50 where we would plot 1 point. This feels like it's taking longer than 5 minutes. I wonder if it gets worse as it goes down because the numbers get larger. better off writing the alternative method of parsing it rather than waiting for this to run. Yes, finally. I think that was more like 15 minutes. Let's actually look at that. If this is all zeros, I'm going to be furious. Good, that looks correct. So now, I don't think we want L. We don't want A to I50 or go past. So what we're going to do instead is RB star in 2, 3, 4, 5, 6, 7. Let's go to on x1, y1, no, sorry, x1, x2, y1, y2, z1, z2. Right. And actually, we'll run that to make sure it's printing the output correctly. And then I'm going to try to write the whole program really carefully and get it right the first time. Yeah, so that only took like 10 seconds to pass the input instead of 15 minutes, so that's good. We've spent the 15 minutes, we don't need to spend them again until presumably part 2 where the ranges increase. Okay, so now we need a few functions. We want to make a 50 by 50 by 50 cube. Sorry, it wants to be a bit set. So cube is bz malloc, 50 z's, 50 y's, and 4 x's. So we'll have a lookup table for x divided by 16 again. And this, this wants to be x divided by 16x, and it wants to be and powers of 2 x mod 16. And to set the bit, something like that. And now to set all the x's in a range, to n, so if we're aligned at the start of a bit and the whole range fits in one bucket of our table, then we don't need 16 calls to bit set. So in this case, we know that cube z, y, x divided by 16 becomes v. Otherwise, and x against 16. Otherwise, we just bit set x, y, z to n, and x gains 1. So do we think that's right? If x is aligned to the start of a cell and x plus 15 is within range of the cell, and x plus 15 is less than or equal to x2, well, the values that we're going to set are x plus 0, x plus 1, x plus 2 up to x plus 15. Okay. So that seems correct. So our range is actually 101 points because we've got 50 negative and 0 and 50 positive. So if we set max x is min x plus 50, then on the first run we'll be going from minus 50 to 0, and on the second run we'll be going from 1 to 51. So and then we want the same pattern for y. Actually, how many? Yeah, so we can actually do, well, how many do we need? If we're going up to position 101, then that's 7. So what we'll do is z and y will be chunked up, but x will do the whole thing. Well, min y is less than or equal to 50. Max y is min y plus 50. If max y is greater than 50, max y equals 50. And now what we want to do is walk over all the instructions. Oh, firstly clear out the cube. And we need a count as well, don't we? Count is a bigint, actually. Firstly clear the cube, then walk over the instructions, and for each point, or for each range that we need to do, we'll so n comes last. So say x1 minus nx, x2 minus min x, y1 minus min x, y2 minus min x. No. x1, x2, y1, y2, z1, z2 on. X minus v1 minus min x. No, hang on, I'm confusing myself here. These don't want to be minus min x. Or do they? Well, they need to be in the range 0 to so if x1 is greater than max x, x2 is less than 0, and y1 is greater than max y, y2 is less than 0, or z1 is greater than max z, or z2 is less than 0, then we don't have to do any work, because we know we're not going to set any points. Now, if x1 is less than 0, then we set it to 0. If x2 is greater than max x, x1 is max x. Okay, I will make sure to read over it all in a bit, just to make sure it's all correct. So now we have set range. zy, x1, x2, n. Okay, that's that range. We need clear cube and count cube. Whatever. Okay, that's clear cube. Count cube wants to do the same thing. Maybe we don't want a function call on everyone. Maybe we'll just have count cube also clear out the cube. Now, we only gain anything if it's not 0, and if they're all set, we'll gain 15, 16. Otherwise, count how many bits are set, and if count latent gets high enough, then I'll begin to count. So count bits we need. Okay, test each bit of x. If it's set, then n++ and return n. And finally at the end we just need to print the count. Okay, I think that might be all. I'm going to read it all top to bottom and see if I've made any obvious blunders. Oh, I have. It should be x divided by 16, not 16 divided by x. Maybe stuff like count bits should be written in assembly language. So min x is going to be -50, and then 1, and then 52. So yeah, that's going to be right. Okay, let's try that then. Actually, I'm just going to add a progress indicator. So I've noticed that min x should always be -50, but this loop wants to be over z rather than x. So, yeah. Min x is always -50, and max x is always 50. Oh, for some reason I wrote min x for all of these instead of whatever they should be. Why is var not allowed here? What the hell? Why is var not allowed there? I think it thinks this is inside the loop. I think that's a compiler bug. You're not allowed to declare a variable inside a loop because otherwise it would leak stack on every loop iteration because of the way it works. However, this isn't actually inside that loop, although to the parser it appears as though it is. So what am I going to do about that? We've already got globals with all of these same names that we're no longer using. So I think we'll just reuse the globals. Yeah. That's one to look at though, isn't it? So the answer to this one was 39, I believe. Okay, that should be less than or equal. So it takes about 6 seconds per one on this very small input. So I assume the majority of that 6 seconds is spent in the cube count function. Now, why were they all 0? Oh, because we forgot to add I think it's that. No. Cube size, cube size, cube size x. Cube size, cube size, cube size x. Okay, so we're not calling set range. Yeah, I am pushing the things I read in onto instructions. So for some reason, x1 is greater than max x, or x2 is less than 0. Well, I'd really like to leave that in because it will save a lot of work on the ranges that don't actually cover any points. But let's see what happens if we take it out. I wonder if it's just a precedence problem. I need to put brackets around everything. I don't think so because I think I checked that and convinced myself it was all fine. After the last time I was confused about the precedence. So where do all these 60s come from? we need to subtract off min x from these. Well, call it range. Okay, range is just max minus min. Didn't we already have min z equals 1? What the hell? So what's happened here then? Do we think the program is actually wrong? Or do we think it was the funny compiler problem again? Ah. Maybe it's to do with that, but I don't think it should matter if we pop an extra thing off the stack. Let's try it anyway. Well, it certainly wouldn't matter the other way around. It wouldn't matter if we'd passed an extra argument to cube count from global scope. But does it matter if you pass one too few arguments? Don't know. Yes, good, getting somewhere. Let's get rid of the spammy output and see what it says on the real input. Pretty good. Right then, let's see what it says. My prediction is it will take too long. Right, so that's 6:59:25, which means it's taken me 2 hours to get to the point where I can even run it. It's just occurred to me that perhaps I'm going about this completely the wrong way, because if you've only got 2 ranges that you need to turn on and off, then you can calculate the number of cubes that are turned on using the intersection. So for example, if both instructions turn cubes on and there's no overlap, then you can just multiply the area, multiply x, y, z of each cube to get the total turned on and add them together. If one of them's an on and one of them's an off, then you work out the area of overlap and subtract the overlap from the amount that's turned on. And if they're both turned on and there's some overlap, then you add for them both and subtract the overlap because you've double counted it. But how do you generalize this to more? Well, it's taken 6 minutes so far, and we know it's going to take at least 4 times that long. Yeah, so that is exactly what it is. So what I've worked out on paper is if you've got a bunch of squares that overlap, then the easy way to add up the total area covered by the squares is to go over each square, add on the volume of that square to your total, and then for each other square subtract off the volume of the overlap. And if every square is turning space on, then that's it, that's your answer. If some of the squares are turning space off, then all you need to do is not add the volume of that square on in the outer loop. In fact, the outer loop only wants to look at the squares that are turning space on, because the squares that are turning space off get subtracted out anyway when the other squares consider them. But actually, yeah, no, that's correct, because if there are two squares in exactly the same place, both getting turned on, then we'll, with area 4, then we'll add on 4 and then subtract 1 off for the corner that's subtracted away. No, that's not completely the answer. Just subtracting the overlap isn't enough, because you'd end up subtracting the overlap twice. So I think for each cube A, you only want to go over the later cubes B to add up the volume, assuming all cubes switch area on. I think if all of the cubes were turning space on, I can see how to handle that. That is just for each cube A, add the volume of A, and then for each cube that comes after A, subtract out its volume, subtract out the volume of the overlap between A and B. But I cannot see how to generalize that to allow cubes that switch space off. I expect part 2 is going to be you have to do the same thing, except forget the minus 50 to plus 50 bound. So we're going to have to figure this out for part 2. Actually, didn't the problem say something about a maze? I suppose if it were a maze, then it's actually easier than the overlapping volumes problem. I mean, modulo time and memory constraints, because to work out if a given cell is blocked off or not, you just start at the end of the list of instructions and walk backwards until you find a step that writes to that cell. And if it's an off, then it's off, and if it's an on, then it's on, because whichever was the last thing that applied to that cell is what the cell ends up being. Actually, my idea for subtracting out the overlapping volumes won't work, because if you've got 3 cubes that all overlap the same point, then we would subtract out too many copies of that point. Okay, let's submit that. I hope it's right. That took about 29 minutes. Yes! Thank God for that. If problem 2 looks like it's going to be very difficult, then I might just fix the compiler's local variable bug instead. Well, part 2 looks like it's going to be long. Wow. Yeah, okay, this is the hard version. Well, I can't even see how to do it if you want all cubes on. Well, I might commit my part 1. And yes, we will try to fix the compiler bug. No. Oh well, we can't fix the compiler bug then. Never mind. That's probably the end, in which case, thanks for watching, goodbye.